Okay, so the first thing that we're going to learn about this unit is factoring by GCF. Before we can move on, you have to understand what GCF stands for, which you all know, I'm sure, and it stands for greatest common factor. But before we move on, you have to know the difference between a prime number and a composite number. So an example of a prime number, or excuse me, the definition of a prime number is a natural number with two unique factors, one and itself. So, for example, the number 3 is considered a prime number because it has two unique factors, unique meaning different. So the two unique factors that 3 has are 1 and 3. The number 1, though, is not a prime number because the only factor that 1 has is 1, so it's not considered prime. A composite number, however, is a number with more than two unique factors. So an example of a composite number would be a number like 4 because its unique factors are 1, 2, and 4. So it has more than two unique factors. Now to find the GCF of a set of numbers, you're going to look for the lowest exponent, but that's something we're going to get into shortly. So let's do some practicing with finding the GCF of some numbers. This is all stuff that you already know, but we're just going to do a quick review of it. We have two examples. I'm going to show you two different methods that you can use to find the GCF of just some natural numbers. So the first method is by creating a list of all the possible factors of the number. So for example, you see how there's an 18 right here. So we're going to list out all the possible factors of 18. I suggest for right now that we just go through this using brute force. So, for example, 18. Let's start with 1. 18 is divisible by 1, so 1 is a factor. 1 and 18 multiply together to give you 18. 2 is also a factor because 18 is divisible by 2, so another set of factors would be 2 and 9. 3 is also a factor because 18 again is divisible by 3, so we'll have 3 and 6. 18, however, is not divisible by 4. It's not divisible by 5. It is divisible by 6, but 6 is already in my chart, so that means I've completed my list of all possible factors of 18. Similarly, I'll do the same thing with 24. So 24's factors are 1 and 24 to begin with. It's divisible by 2, so 2 and 12 will work. 3 will work, so 3 and 8 are multiples of 24, and 4 will work because 4 and 6 are multiples of 24. 5 will not work, and then the next number that does work is 6, but again it's in our list, so we don't have to keep going with our list. So then, because GCF, we said, stands for the greatest common factor, we're going to look for the biggest factor that's in common with all of these guys right here. So the biggest factor, if you can tell from our list, is going to be, let me just pull it up, 6. So 6 is going to be my GCF. So what I'm going to do is I'm going to say that 6 is my GCF right here, and then we're going to divide each number by the GCF just so that you can get some practice before we move on and actually do some factoring by GCF. So 18 divided by 6 is 3, and then 24 divided by 6 is 4. So that's one way to do it. But this can get quite cumbersome if you have a large number that you want to find the factors of. So another way to do it is by doing factor trees. So our next example has 90 and 315. So 90 is divisible by 9 and 10. So 9 times 10 is 90, so those are two factors. Then I look and see where I can break off each one of these numbers. So 9, I'm going to look for factors of 9 now. So some factors of 9 are 3 and 3. And then I'm done with this part of my factor tree because 3 and 3 are both prime numbers, so I can't go any farther. Similarly, I'm going to do the same thing with 10. So 10, its factors are 2 and 5, both of which are prime numbers, so I've gone as far as I can for 90. So then if you look at this right here, I can say that 90 is all of the following factors multiplied together. So if you look right here, I'm going to say that 90 is 2 times 3 times 3 times 5. Okay? And then I'm going to do the same thing with 315. So I'm going to look for some factors of 315. I see it ends in a 5, which means it's divisible by 5. So I'm going to try 5 and 63. And then I'm going to look at 63, and I know 63 is divisible by 9 and 7. 7 I'm done with because it's prime, and 5 I was done with because it's prime. 9, however, is composite, so I'm going to keep going with that. 9's factors are 3 and 3, so then I can say that 315 is these prime numbers multiplied together. So my numbers will be 3 times 3 times 5 times 7. Now, greatest common factor is what we are looking for, so we're going to find the greatest number that's in common with with both of these numbers right here. So I have a 3 in common, I have another 3 in common, and I also have a 5 in common, which means that my GCF is going to be 3 multiplied by 3 multiplied by 5, which is 45. So now I know my GCF is 45, and then if I divide out my numbers, I get 2 and 7. Here's a little shortcut. You just look and see what's left over. So for example, if you look at 90, my numbers that I have left over is just 2, so that's what I get when I divide it by the GCF, and then 315 when I divide it by the GCF, I have a 7 left over. One thing that you should notice is there is nothing in common with the numbers left over that are being divided by the GCF. That tells me that I know for sure I took out the greatest common factor. Okay, so now this is where things get a little bit more difficult. So now we've got some variables, and we still want to look for the greatest common factor. So same thing that we did before where we list out all the possible factors of a number, we're going to do the same thing with our variables. So as you all know, x to the 8th power means x is being multiplied by itself 8 times. So if you look right here, written in blue, you can see that the x is being multiplied by itself 8 times. So x to the 7th means I'm going to have 7 x's being multiplied together, and then x to the 6th means I'm going to have 6 x's being multiplied together. So now I'm looking for what's in common, so I'm going to highlight all the x's that I have in common with all 3 of my terms. So I've got 1, 2, 3, 4, 5, and 6 x's in common, which means that my GCF would be x to the 6th power. Don't forget that we talked about this earlier, that when we're looking for the GCF, the shortcut is just to look for the lowest exponent. So, for example, the lowest exponent, that's in common with all of the variables. So, for example, if you look at this right here, the lowest exponent that's in common with all of my variables here is x to the 6th power right here. 8, 7, 6. 6 is my lowest exponent. So then to divide it, don't forget that when you divide, you really need to just subtract your exponents, because x to the 8th power divided by x to the 6th. 6 of the x's cancel out. You've got 2 x's left over, so it's x squared. X to the 7th power divided by x to the 6th is x. And x to the 6th power divided by x to the 6th power. I want you to be really careful. Make sure you don't say cancel, although it is true that they cancel. I want you to get in the habit of saying that it divides out to give you the number 1. Okay? Alright, so that's what happens if you have just one variable. But now we need to look at what happens if you have coefficients, if you have different variables, what's going to end up happening. So, for example, in number 4, you have 9a to the 4th power, b to the 3rd power. So I'm going to look at 9 to begin with, and I'm going to see how many, or what are the factors of 9. That's nice and easy. 9 has 2 prime factors. Those factors are 3 and 3. Then I'm going to list out a to the 4th power as 4 a's being multiplied together, and b to the 3rd power is 3 b's being multiplied together. So that's what it looks like right here. Similarly, I'm going to do the same thing with my coefficient of 15. So 15's factors are 3 and 5, and then a to the 3rd means 3 a's multiplied together, and b to the 2nd means 2 b's multiplied together, so it looks like that. And then 3a squared b to the 4th, 3 is prime, and then everything else is exactly like we talked about before. So same thing, I'm going to go through and I'm going to highlight everything that's in common. So I've got a 3 in common, I've got an a in common, I have another a in common, and I have 2 b's in common. So that turns out to be 3 a to the 2nd power b to the second power is my GCF. Okay, and another way to think about it is just look at the coefficients. You got 9, 15, and 3. What's the largest number that can go into all three of these numbers is 3. Then you look at your a's and you look at your exponents for your a's. So you've got a to the fourth, a to the third, a to the second. The lowest exponent would be a to the second. And same thing for your exponents for your b's. You got to the third, to the second, and to the fourth. So again, to the second power coincidentally is the lowest exponent for this as well. So then when you go through and you divide it out, 9 divided by 3 is 3. A to the fourth divided by a to the second is a to the second, and then b to the third divided by b squared is b to the first power. Again, you can see right here you've got a 3 left over, an a squared left over, and a b. Same thing, 15 divided by 3 is 5, a to the third divided by a to the second is a, b squared divided by b squared, remember we're going to say is 1, but anything times 1 is itself. And then lastly, 3 divided by 3 is 1, a squared divided by a squared is 1, b to the fourth divided by b to the second is b squared, so we don't need to write the 1's out, it's just b squared. Okay, so let's just do a quick review. In question number 5, you see the problem where it asks you to distribute, so I would like you to distribute the 3x to everything inside of the parentheses. Please press pause, go ahead and do your distributing, and then when you're ready to go ahead and press play again so you can see if you get the same answer that I did. Okay, so once you distribute it, you should get 3x to the fourth plus 24x cubed plus 12x. So now the next thing that it asks you to do is find the GCF of your answer to number 5. So the answer is what's written in blue right here. So what I'm going to do is I'm going to look at my coefficients. My coefficients are 3, 24, and 12. So the largest number that's in common with 3, 24, and 12 is 3. And then this is a little bit on the easier side because there's only one variable. So what I'm going to do is I'm going to look at each one of the exponents. I've got x to the fourth, x to the third, and x to the first. Looking at all three of these exponents, it's clear that my lowest exponent is x to the first, making my GCF 3x. Now here's something very interesting that I want you to do. Just like we did before, I want you to divide all of the terms, so all of these blue terms, by the GCF of 3x and see what you get. So 3 divided by 3, right here you got this 3 divided by this 3, you get 1, and then x to the fourth divided by x, you get x to the third. And then 24 divided by 3 is 8, x to the third divided by x is 8x squared. And then 12 divided by 3 is 4, x divided by x is 1, 4 multiplied by 1 is 4. So you get x to the third plus 8x squared plus 4, which should look familiar to you because we have that right here inside of our parentheses. And our GCF is the number that's on the outside of the parentheses. So basically, when you're factoring by GCF, all you're doing is you're just going to undistribute. Okay, and that example is shown right here. Okay, so now that you know how to find the GCF and divide terms by the GCF, we are going to actually factor by GCF. Now, in order to factor by GCF successfully, you just need to do the following things. Step number 1 is to find the GCF, which you already know how to do. And then step number 2 is to divide the expression by the GCF, which again you already know how to do. Lastly, you're just going to write your answer as the GCF multiplied by the quotient, just like all the other expressions look like when you before you distribute it. So you've got your GCF on the outside and then your quotient on the inside. And that's just basically like what we said before, where you're just undistributing your expression. So step number 1 in question number 6 is to find the GCF. So the first thing you're going to look at are your coefficients. So your coefficients are -5 and 25. So you're going to look at your coefficients and decide what is the greatest common factor of -5 and 25. Here's where it gets a little tricky, and that's because the leading coefficient is negative. Because the leading coefficient is negative, you want the rest of the, you want the GCF to be a negative number. It's not necessary that you do that, but it will make things very much easier for you in the future if you do that. So the GCF of -5 and 25 is going to be -5, Then you're going to look at your variables. Look at each variable separately. So let's look at the x's first. You've got x to the third power here, and you have x to the first power. Remember, we're going to look for the lowest exponent. So the lowest exponent in common with the two variables, excuse me, with the x's is x to the first power. Then look at your y's. There's y to the first power here, and there's no y's here, so it's technically y to the 0th power, making the lowest exponent y to the 0th power, but don't forget that anything to the 0th power is really just 1. So it's like I'm multiplying by 1, which is exactly the same number. Another way to think about it is, since the C in GCF stands for common, there's no y in common with the two terms, so there should be no y in your GCF. All right. So step number 2 is to divide the expression by the GCF. So what we're going to do is we're going to take the original expression right here, and we're going to divide each one of these terms by the GCF. So for example, right here we have -5 divided by -5, which would give you +1. X to the third divided by x gives you x squared. Y is being divided by 1, so you get y. Plus 25 divided by -5 is -5, so I really shouldn't put a plus there. I really should put a minus sign there. So minus 5, and then x divided by x is 1, so they cancel each other out. So your expression right here would be x squared y minus 5. Lastly, you are going to write the answer as the GCF multiplied by the quotient. So I'm going to take my GCF, which is -5x, and I'm just going to simply write it on the outside, and then the quotient will go right on the inside. So this will go on the inside of my expression. And this is my answer in factored form. All right. If I want to make sure that I did this correctly, all I have to do is go through and distribute these two numbers right here, and I should end up getting this expression right here. So why don't you take a minute to actually go through and distribute it, pause the video, and see if you get the same answer as what the original problem said. If you did it correctly. Okay, one last thing that I want you to be aware of is if you look inside of here, there's nothing in common with my two terms inside of my parentheses right here, which means that I took out the greatest possible common factor. All right, one more example like this, and then we will do solving literal equations with GCFs. So let's look at this right here. Step number 1, find the GCF. So I'm going to look at my coefficients, 4 and 7. Now here's a tricky question. 4 and 7, the only common factor that they have is 1. So my GCF so far is just going to be 1. Now I'm going to look at my variables, and I've got x to the second power and x to the first power. So my lowest exponent is x to the first power. And then I'm going to look at my y's. I've got y to the first. So my GCF is just plain and simply xy. Next, I'm going to take my expression right here, and I'm going to divide everything by xy. So 4 divided by 1 is 4. Four divided by 1 is 4. X squared divided by x is x. Y divided by y is 1. Plus 7 divided by 1 is 7. X divided by x is 1. Y divided by y is 1. So that is my expression that I get when I divide it. Last thing I'm going to do is write my answer. With my parentheses. So I'm going to make it look like I undistributed it, which is what I did. And that's my final answer right there. Again, to check to make sure that this is right, I can always go through and distribute the x, y into each one of these terms, and I should get the original expression. Alright, now I need to solve a literal equation. And here I'm going to try to solve for a. Now I have an issue with isolating a, and that's the fact that a is in both terms on the left side of my equation. So what I'm going to do is I'm going to go through and I'm going to factor out my a from both of these expressions. So I have an a in common right here. I'm going to factor it out, and I end up getting 5, because 5a divided by a is 5, plus 10x, and that's equal to 4b. Then, to get this a by itself, it's multiplied by this whole entire expression, so I'm going to divide everything by 5 plus 10x. And that means that my final answer will be, a equals 4b over 5 plus 10x. Alright, let's do one more example just to make sure you're okay with this. So this time I'm trying to solve for y, but again my problem is that there's a y in both of my terms. So I'm going to factor out a y. So I'm going to use y as my GCF. Now, if you guys notice, there still is a number in common with the 3 and the 9, but I'm not going to bother factoring that out because I don't really want to factor out the greatest common factor. I just want to get the y out of there so I can isolate it. So I end up getting 3x plus 9, the entire quantity multiplied by y, is equal to 14. Again, divide everything through by 3x plus 9. And that gives me my final answer of 14 over 3x plus 9. All right. Hopefully this was helpful.